In this tutorial, we're going to talk about recursive functions. A recursive function is a way for you to improve the readability and efficiency of some code. Let's take the example of a factorial. So I have written this factorial function, and I'll show it to you real quick. Essentially, it returns a single integer of 32 bits, and it takes a single parameter, and we check if that digit is equal to 1, or if it's equal to 0, and we return 1. If it's not either of those, we're going to go down here, we're going to print it in our log, and what we'll do is we'll return the value of our factorial digit times what our recursive function with the same digit that came in minus 1. So essentially what's going on here is we are using it's a method of calling of a function calling in which a function calls itself during its execution. So right here, we're calling our function inside of itself. Now, for our example, we're going to be doing a factorial. A factorial of factorial digit is the product of every number from 1 to factorial digit. So if we put 4 in this, and we were to run this, what we would get is this. We'd get factorial's digit equals 4. So what happens is, when we print the info, because in our begin play function, we call the print info function, which will go down here and print this line, which we're saying the factorial digit is 4. In the next part of it, we are printing what we call the recursive function. And what's going to happen is this isn't going to print out yet. What will happen is once this gets ran, it will then print out our factorial digits. So our first factorial digit is 4, the next one is 3, then 2, then once it hits 1, it's not going to print anything, but what it'll do is it'll finish the execution of that function, and it will call and print out itself. So the call to the recursive function is, well, is equal to 24. So 4 times 3 times 2 times 1 is essentially the factorial of 4. Now, this is probably pretty simple if you've taken any sort of math before, but if you think about what's happening here, if we are calling this function every time inside of itself, that means that every time this function is called, it is placed into memory. Since we are not exiting this recursive function until it reaches our factorial digit equals 1 or 0, the number of functions, which will be factorial digit, will reside in the memory of the program. So with our example 4, it wasn't really a problem, but other functions, let's say we did the factorial of 300, that could maybe lead to serious memory requirements, and you might want to just be aware of what you're doing with a recursive function. Now, most of the time you might not need to do a recursive function, but like I said, recursive functions are really easy to program, and it's really easy to program, and it's really easy to get ahead of yourself within it. So this is just I just wanted to show you that you can call a function within inside of itself, and what that's called and how you would do that. We won't go over too many more recursive functions. Maybe we could do the print out the Fibonacci sequence or something like that. But just be aware that you can call a function within itself.